Warahmatullahi wabarakatuh. This is our group. But first of all, my name is Nizar bin Azman. My matrix number is 17365. So we have 4 members in our groups. So I'm the first one, and second one.
Hi, I'm Lee. Also the same department, the same classmate with him. So
I'm Aik from Computer Engineering.
And me, Razilin Julie, same coursemate with Niza and Lee.
So today we would like to explain about the report that we need to do, the assignment 2 actually. For the introduction of our report, we actually have divided our parts. Me have my parts, and all of my friends have their parts. So my parts actually based on the filter of the low pass filter. For the basic understanding about the low pass filtration, actually the the low pass filter is something, the signal that we get, and we only consider the low pass, which we cut off all the high frequency and all the unwanted signals that enter that we need that we get. So we just consider the low pass. So that's the general understanding about the low pass filter. So for the high pass, I would like to invite my friend Farid. Pass.
Okay, thank you, Niza. Okay, now we explain about basic concept of a high pass filter. Okay, from my knowledge, what I get from some reference. Okay, high pass filter is a filter that we filter the low frequency of signals, and then then we just record, or we get the high frequency of signal only, and then the low frequency of signal, then we will remove by using the high pass filter. Okay, the low pass filter is such as voice of humans, the music, the guitar instrument voice signals. Okay, that's all. Okay, now I will pass to Aini to proceed our next sessions.
Okay, so far band pass filter. This filter consider two filters, which is high pass filter and low pass filter. Where high pass filter will remove the unwanted lower frequency. So it will consider both of them, and it will have two cut off frequency. So I pass to Ali.
yeah, so my part is the band stop. So band stop is just let's say if you have a video, you want only the background music, but you don't want the human voice. So you can use the band stop and just give give an inverse of the human voice, and then use band stop. You can take it off. So at the end, finally you will got the background music. So band stop is just to cut out some voice that you don't need, and then you will finally got the voice you want. So that is band stop. Okay.
Okay, thank you, Lee. So now we would like to proceed to the reports that we get. So first of all, I would like to explain to you for the low pass filter. Farid, can you help me?
Okay, sure. Aini.
Ain, can you help me?
This one.
Okay, this one. This one is the reference that given by the doctor. So this one is our report.
Okay.
So this is our report. So low pass. As you can see, the end here, this one, the end here, this one, the end here, this represent the number of sample that we get to make the graph. So can I proceed the graph first so that you can understand better. So based on the graph, we can get the both phase graph and the magnitude graph. On the magnitude on top of the phase, this one, we can see that it is only considered the low frequency. Only consider this one, this and until this one. Before and okay, we continue for the low pass. For the low pass, we have magnitude and phase. For the upper one, it is a magnitude. So the magnitude, this is the graph. So the graph that shown actually shows that we only consider all the low pass frequency. The frequency that already filtered by the low pass. This is the frequency. All the unwanted, such as for the sound signal, if there are the kick drum, it is an example of the unwanted signal for the input. It already filter it, so this will be the graph. So for the phase, the difference is phase do not have a scale, so the graph will be like this. So next, this one is the impulse response of low pass. The graph will be the amplitude spectrum. So as you can see, we can get the amplitude. So the amplitude shown is 0.06, and the x-axis will be sample and the y-axis will be amplitude. So we get the result of impulse response of low pass. Next, this is the audio input. The blue one is the input of the audio before we filter the signal. So you can get actually there's too much unwanted signal that in the graph. So we go to the second graph, which is green graph. This one is already filtered, so we get the signal, the true signal of the low pass, the signal that have been filtered by the low pass. Okay, this one is time. This one is time domain. Okay, Farid, next. So this one is frequency domain. As you can see, the graph is discrete. The x-axis will be frequency and the y-axis will be input signal. After this one, actually the first graph is actually the before the filter, the low pass filter, and the second one is after the filter. As you can see, there's a flat line in the bottom of the graph, so it will be already filtered. Okay, so next. Okay, my part is already done for the figure, for the graph. So next, Farid, can you explain to me what is the
High pass.
the high pass.
Okay. Just now I just explained the concept of theory of the high pass filter. Okay, now we proceed to the graph. Okay, for high pass filter, okay, we have set the cutoff at the 8,000 gigahertz, 8,000 hertz. Okay, and then this is after that we get both amplitude and phase response. Okay, for example this one, okay, for magnitude and phase. Okay, for magnitude at the top graph. Okay, the high pass filter it remove the low as you can see that this graph will increase, and then the high pass filter will remove the low amplitude of voice or signals, and then we get the flattened graph.
Farid, can
okay.
I ask you a question?
What is it?
Where is the cut off of this graph?
Okay, this one, as you can see, this one. Can you see
on
clearly?
the top of the before the
Yeah.
flatten. Okay.
Because we can see that it flattened, right?
Okay.
Okay, now I proceed to the phase. Okay, the phase is same with the but it's the different type of degrees. And then I will proceed to the next one. Okay, and this graph of impulse response of high pass. Okay, this is between amplitude and the ensamples. Okay, as you can see, there's this amplitude spectrum graph. Okay, next I will proceed to the where is it? Okay, this okay, this time plots of impulse and output high pass. Okay, for the input, this graph show that many voice that we get through the audio records. So then after we filter by using a high pass filter, and then we get this one. It has the range between the range, and they will, after the high pass filter, between the range they will record it. Okay, the low voice signal will be removed. Okay, next. Okay, this is the last part for my part. Okay, for this one is between input and output spectra high pass. Okay, as you can see before that, okay, they have a very what we call it as a very
Small like this.
very rough graph. And then after we filter it, and we get this one. Okay, that's all from my part, and I will invite Ain proceed our discussion.
As I told before, this is the band pass, which is considered the high pass and low pass filter. So the graph of frequency response band pass, it will be like this. This is the low pass, and this is the
No, high.
high pass.
No, actually, I think this one is high, right? This one is low. Because based on my graph that I explained before,
It will
the graph will be
increase
going
for
down.
high pass.
Right?
yeah, sorry.
Sorry.
Okay. So this is the phase. This is the magnitude of graph, and this is the phase. So the cutoff, as you can see, for band pass, it has two cutoff frequency, which is cutoff for low pass 2000, and the cutoff high pass 7,000. So there's two cutoff, which is here and here. So it'll be like this. Okay.
Okay.
So after that, this is the impulse response of band pass, which is it will shows the amplitude spectrum of the graph. As you can see, it have couple of frequencies.
Frequency.
Because it has the same the same frequency for bandpass, right?
Okay.
Okay, so this is the impulse to that. Okay, then this is the input signal, and this is the input, which is in time domain. And after it filter, it will be like this.
Okay.
So this is in time domain. So after that, this is the spectra band pass, which is the same as before, but the spectra is in frequency domain.
Okay.
Okay, so it will be the same like the others. So I'll pass to Lee.
It's my part, then stop.
Okay.
So then stop. As I told before, we need a inverse. So we have a high, low cut off low part and cut off a high part. So this one.
2, 3.
Okay, so here's the two graphs we got, magnitude and phase. And for the band stop, we want to consider about this one and this one. So it means take off this part. And for this one, well, at least same. So you can see this one, want to keep this one, cut this one. So next, again, this one, the Hamming graph. Well, actually, this one is the same like the previous one, but it's just a different way to present. So we want to keep this one, this and this part, and move on to this one. So next one. Well, this one shows the input and output. For the input, well, actually everything is same, so it's just on top. And for output, after we take off, and finally we got this one, which is what we want. For example, the background music. And this one is a graph to show, well, is to show the input and output, and well, like the previous one, the blue and the green one, but this is again a different method to present. So you see, this one is the original one, and after the order, so we got this one is what we want. And so hold this part, we just cut it, so make it small. So that is all for my part.
So I think that's all for the explanation about the graph by different of the filtration which we explained it before. So that one is a noise, right?
Yeah.
That one is noise.
How about
So-
the pictures?
Yeah, for the picture, we would like to proceed for the picture. Okay, can you click for the picture filtration? Okay, this one is the 8 picture that we have to explain. That we need to explain. So we already divide what we need to do. then for me, I will spin the first two of the picture, and the rest you also see they have to explain the two picture. So for me, my part, can you zoom to the laptop? As you can see, there is a 4 picture that with a different filtration. So the first one is original image. For the original image, there is no filtration. This image is originally taken by the camera. So, can we proceed to the next on the left, on the right? So as you can see, if we use the filtration of the noise on that picture, we can see there's a lot of dot, the color of dot.
What do you mean spot?
Yeah,
spot?
The color spot.
Okay.
There's a blue, yellow, green dot in the picture if we use the filtration of the noise. And if we proceed to the bottom right, bottom left, this one we use the filtration of the
Color.
Because so the result will be the gray image of the picture. So for the last one, as you can see, if we use both of the filtration, which is noise and the color, and this is we get after we filter the picture from the original that we taken from the camera, there will be the spot and it will be gray. Okay, so next, this one is figure 1. So figure 2. So as you can see, this one is just similar as the graph from the noise graph, but the scale of the graph will is more bigger. As you can see, this one is a low pass based on the picture filtration. So this one is a phase and this one is magnitude. This one start from the 20, and for the phase it will start from the 0. Okay. Then I think that's all from me based on the explanation of the picture. So now I would like to invite Fahri Azmi to explain the next picture.
Focus on the figure. Okay, the figure, as you can see, this is impulse response of Heidi Hamming. It is between amplitudes and the samples. Okay, as you can see, these straight lines in verticals.
Amplitude spectrum.
Yes, exactly, amplitude spectrum. Okay, there's and the highest peak of the amplitude spectrum is the 1s. Okay, next, okay, Ain, can you show me the figure?
The
next figure. Okay.
Wow.
Oh, this look
this one
interesting.
is different.
Yeah. Okay, the first one is a desired frequency response of 2D. Okay, next, we interpret the data into the it's also the actual frequency response of 2D Hammings. Okay, as you can see, there's a lot of colorful colors, right? Okay, that's all. Then I will pass to the Ain to proceed the next figure.
So this is the next figure, which is this. This is the original image,
Okay.
which is smooth and okay. And then after that, it filter. I think it's filter to be more what?
Blur.
Yeah, more blur.
The sharpness.
The sharpness. Yeah. So after that, this is the noise image, which is same with Niza said before. So it will it has dots everywhere. So this is the noise image after filter both. So it will become like this.
Blur and
Blur and
lots of
lots of noise.
Oh, okay.
okay.
So this is the convolution kernel of gray image, and this is the noise gray image. So as you can see, the sharpness.
Yeah, I think the sharpness.
The sharpness of
The graph.
the graph.
Which is more sharp, you think?
I think this one.
Yeah.
Because we can see the rough of
Oh, okay.
lot of rough surface.
The smallest the scale, the more sharpness it will be.
Yeah.
Is it Lee? Are you agree with me?
I think so.
Oh, okay.
Okay, so I pass to Lee.
Okay. So this is my part.
Yeah.
Well, I'm sure everyone will see these two pictures look familiar, right? So actually, this graph shows a picture change with image diagram. So according to the original one, you see this one is from the 0 to 250. Well, actually it's a little big, but never mind. So then after we change it, see the next one, we make the scale become larger from the beginning to 250 until the 600. So if we explain this, it will like somehow this picture we give a big background, but actually there are nothing there. So in reality, this picture will actually become smaller. So when the smaller picture zoom out with the original size, it will finally become not clear, and we will got this one. So next. Thank you.
This is the last graph.
This one is just okay. So this one is actually same as the last one I talked, but the only difference this one is a lot of dot. So as you can see, after change, this will become not clear, and due to that, well, the dot is also become not clear. So that's all I think.
Okay, Lee. Thank you.
Okay.
So
Okay, I think Nizar can make a conclusion for our discussion.
I think
right?
yeah, sure. I think that's all from us to explain to doctor what is actually the filter is about. There are many filtration that we need to use to make the video, the noise become better. So just now we already explained just 4 of the filtration, so that you can use to make your video or the noise that you record become more better to hear or to see for the audience. Okay, I think that's all from us. With that, I think thank you very much to give the assignment that very fresh knowledge for us. Yeah, very challenging.
I like your
but
sound.
we accept the assignment to make ourselves better. So
Yeah,
I think
thanks
that-
everyone.
that's all from us. Farid, you want to say something?
Oh, I don't have to say that. Maybe you can jump to
Okay,
No,
I think
discussion.
that's all from us. With that, we thank you.